Now that you can program your robot to move forward, you are ready to complete the Forward Unto Dawn worksheet. You must set your left and right wheels to the exact same speed so that your robot travels in a straight line. For the first 3 rows, your robot is going to moving at a speed of 50, and for the next 3 rows, your robot will be moving at a speed of 100. You will see that the instructions say complete each horizontal line before you move on to the next one. This is very important. So let us look at the first horizontal line. You are going to program your robot to move at a speed of forward at a speed of 50 for 2 seconds. Your first thing is to predict the distance traveled. Obviously, you have no clue how far this robot is going to go. So whatever you write in this column is going to be correct. Just let's be sensible here. Don't put 2 kilometers or anything. Okay, so I'm going to put a random figure in here. Oops. Not like that. I'm going to put a random figure in here. Then I'm going to run my robot 3 times. Each time I'm going to measure how far forward it moves, and I'm going to fill the value in. Now the figures I'm putting in here are wrong. They are not the figures that you're going to find. They are just for example. Okay, so let's say that the first one it went 6 centimeters, and the second one it went 8 centimeters, and the third one it went 7 centimeters. You put them all down. Then you've got to fill in the average distance traveled. Remember that average is the number of points added up divided by the number of points. I mean the figures on the points added up. So 6 plus 8 is 14, plus 7 is 21. We divided by 3 because there were 3 points that you measured. So the average distance traveled is 7 centimeters. Now that we've done that, now we have to fill in this box. I don't know why that's not working. Okay, never mind. How do we fill in this box? We take this figure. It traveled 7 centimeters in 2 seconds. And we're going to use ratio and proportion. This is very simple. It's just logic. We're going to say, if it traveled 7 centimeters in 2 minutes, in 2 seconds, how far is it going to travel in 1 second? So 7 divided by 2 is 3.5. So if it travels 3.5 centimeters in 1 second, then in 3 seconds, it's going to travel 3.5 times 3 seconds, because we're going to run it for 3 seconds. Okay, and of course 3.5 times 3 is 10.5. So your answer is going to be 10.5 centimeters. You don't need to show the arithmetic. You can just put the result. Now you are going to, that is your prediction. That is your prediction, okay? We don't know yet if it's correct. Now you are going to program your robot to go forward at the same speed of 50 for 3 seconds, and you're going to measure whatever it is. Say we get 12 and 12. Again, these figures are imaginary, and 12. And then we see that the average distance traveled would be 12 centimeters because they're all the same. Now we're going to do the same thing. Now we have to fill in this box. We've got to predict. So if we traveled 12 centimeters in 3 seconds, how far did you travel in 1? Well, 12 centimeters divided by 3 is 4 centimeters. So we're going to estimate here that it's going to be 4 centimeters times 5 seconds equals 20 centimeters. We think it's going to move 20 centimeters. Again, you don't have to put the math in. You can just put the numbers in. Okay, and we can take all of this out. That's all going to be done in your head. And then you're going to measure, and you're going to get a figure. After you've filled in that row, You are now going to run your robot at 100, a speed of 100, going back to 2 seconds. Now your prediction is easy. You went 7 centimeters, going at a speed of 50 for 2 seconds. 100 is twice as fast as 50. So this prediction has to be 2 times that average distance traveled. And this prediction has to be 2 times that average distance traveled. And this prediction has to be 2 times that average distance traveled. It's just logic, okay? So make sure that you make the predictions and make sure that you run each row and use this number to predict the next one before you finish. Then you're going to answer the next few questions. Question 1, estimate how far your robot will travel at a speed of 75, running for 3 seconds. Well, you know how far it's going at a speed of 50 for 3 seconds and at a speed of 100 for 3 seconds. So it should be easy enough to estimate how far it would go at 75. And then run the robot at a speed of 75 for 3 seconds and write down how far it actually went. They should be pretty similar. Scroll down, there are more questions. What is meant by the robot moving at a speed of 50? Tell me what it means in your own words. And then program your robot to move backwards at a speed of 75. Use the snipping tool to copy the move block and paste it under this question. Paste it right here. Then save it to your personal folder and turn it in to my folder on the share drive. Have fun.